As I was looking at your homework, I wanted to clarify something from our particle motion homework. So this was 93, 94, 98 from section 4.4. A lot of you got the correct answers, but I think what you did is you used the calculator to the absolute value. But what I'd like to do is work through a couple of these setups so that you can see the absolute value from the integral perspective. So just as a reminder, remember earlier this year we talked about the absolute value can be broken down into x when x is greater than 0 and then negative x when x is less than 0. It was the idea that if I have the line y equals x, everything in this graph here that was positive stays positive when you take the absolute value. And then all your outputs that are negative become positive. So there's an x-axis reflection for all my outputs that are negative. So that's what that absolute value graph is saying. We have the line negative x when x is less than 0, and this is now the line that's negative x. So using that idea, let's take a look at a couple of the homework questions, just from the absolute value definition perspective. So looking at number 93 on the homework. Part A, the displacement, a lot of you got that with no problem. But then for total distance traveled, we were given that v of t is equal to 5t minus 7, and my t value was going to be between 0 and 3. So we're looking at that very small interval. In order to find total distance traveled, we need to take the integral from 0 to 3 and then take the absolute value of that velocity function dt. Now, what does that absolute value function look like? Well, let's go back to our original definition. And I'm going to start by drawing out the line 5t minus 7. Now, if I go down 7, 5, let's see, 1, 2, 3, 4, 5, 6, 7. And then I've got a slope of 5. So my graph is going to look like this. This blue graph right now is y equals 5x minus 7. And if I want the absolute value, I'm going to be taking everything that's positive, that's still going to be positive, but then whatever's negative is going to have an x-axis reflection. So this piece down here is going to have an x-axis reflection. And the question is, where did that change occur? What is this point right here? And if we set 5x minus 7 equal to 0, we can see x is going to be 7/5. So in essence, what I have here is if my graph is larger than 7/5, so everything over here is still going to be 5x minus 7. But on the other side over here, this is the line negative 5x plus 7. Remember, it's the opposite of the entire function. So if I were to set up an integral for that absolute value function going from 0 to 3, I need to break it into two separate integrals because I'm really trying to find the area underneath the curve of this 5x minus or negative 5x plus 7, and then a separate area under the curve of 5x minus 7. So this can actually be broken down from 0 to 7/5, and we're going to be looking at negative 5x plus 7 dx. And then we're going to go from 7/5 up to 3 of 5x minus 7 dx. And really those should all be t's here because we are in terms of t, but conceptually I just want you to see that absolute value idea. You see where the graph touches the x-axis, and then the graph is going to have an x-axis reflection wherever the output was negative. So this thing right here is what you would be evaluating. And when you evaluate all that out, you should get 113 over 10. Looking at number 94 then, number 94, we were looking at the velocity function being t squared minus t minus 12. And we want to do the interval from 1 to 5. So to start off here, we'll factor this down, and we would get t minus 4 and t plus 3, it looks like. And so I know that I'm going to have t equals 4 and t equals negative 3 is what my zeros are going to be. So t equals 4, 1, 2, 3, 4. And then negative 3 is right here. So there's what my parabola is going to look like. So what I need to figure out then is if I'm going to take the absolute value. So to find the total distance traveled, we're going to go from 1 to 5 of the absolute value of t squared minus t plus 12 dt. Now, if I'm going to take the absolute value, the piece that is above the x-axis, so the output that's already positive, is going to stay positive. And we said right here this is going to be the 0.4 comma 0. So the integral under the curve there is going to be from 4 to 5 of t squared minus t minus 12 dt. So there's my red portion. But then the piece that's going from 1 to 4, I can see there's going to be an x-axis reflection. So this piece right here is going to have an x-axis reflection here in order to have the absolute value. And this green graph right here is the equation negative t squared plus t plus 12. So that's what that green portion is. So then my integral going from 1 to 4 is going to be of negative t squared plus t plus 12 dt. And those are the two pieces that you would integrate in order to find the absolute value piece under the curve. So I hope that makes more sense. A lot of you, as you did the homework, just plugged into the calculator, which is fine. But I wanted you to see the thought process behind setting up the integration when you're taking the absolute value.